Good morning year 2, welcome to maths for another day, happy Thursday. Today to start our maths lesson off we're going to play mental maths train. So I am going to click on a truck and see what questions we need to play. So let's have a look. I think we'll have a go at up to 21 more. Okay, so I'm going to read the question out for you. You can either jot the answer down or say the answer out loud, and then we're going to play this until we get 10 points. So what is 7 plus 1? What is 7 plus 1? Well done, 7 plus 1 is 8. Add together 12 and 1. So pop 12 in your head, count on one more finger. How much do you have? Brilliant, it's 13. Find the sum of 15 and 1. Find the sum. The word sum means the total, so you need to add together your 15 and your 1. So pop 15 in your head and count on one more to make 16. Question 4. Find the sum of 10 and 1. Well done, 11. What is a total of 17 and 1? Pop 17 in your head and count on one more to 18. Fantastic. Add together 16 and 1. 17. What is 1 more than 8? 1 more than 8. So pop 8 in your head, count on one more. Brilliant, it's 9. What is 11 plus 1? 11 plus 1. Brilliant, 12. What is a total of 18 and 1? The total means to add together. What is a total of 18 and 1? Well done, it's 19. And final question, add together 19 and 1. Superstars, it's 20. Well done, year 2. Today in maths, we are going to be finding and making number bonds using our known facts. So on the screen, I have got 2 tens frames, here and here, and I've got sentences over this side with some missing facts in them. So the first one says there are how many black counters? The second one says there are how many red counters? Altogether there are how many counters? So let's start with the black counters. We have got 1, 2, 3, 4, 5, 6, 7, 8. 8 black counters. How many red counters do we have? 1, 2. Now, I've got a full tens frame here. Do you think I need to count every single counter in there? Or do you think I could do some quick maths? You're right, I can do some quick maths. Because I can see that every single space in the tens frame has been taken up with a counter, I know there are 10 in there. Okay, so I've got 10 in there and I've got 2 more up here. How many counters do I have altogether? That's it, I've got 12 counters all together. So the final sentence says, altogether there are how many counters? Now this word altogether means the total. How many counters are on the screen? So again, do I need to count every single counter? Or can I do some quick maths? You're right, I can do some quick maths. I can see that this tens frame is full up, so that makes 10. And I already know that this tens frame is full up, and that made 10. So if I've got 2 tens together, then how much is there altogether? You're quite right, 2 tens is worth 20. Let's just do some sticks to help us. 10, 20. Now the final part of the problem is to fill in the empty number sentences here and here. So let's look. We had 8 black counters and we had 12 red counters. Altogether that made 20 counters. Now I can't just write these numbers in the same places over here, so I'm going to flip them round. I'm going to write 12 first plus 8 makes 20 altogether. And these 2 number sentences are equal to each other. They're the same. They both have the same answer. Now I could flip these numbers round because addition is commutative, and that means it doesn't matter which way round these numbers are, I will always get the same answer. Let's try another question. So let's start with our black counters. How many black counters do I have in this tens frame? Well done, there are 4 black counters. How many red counters have I got? Now look at our tens frame. We've got this one here which is full up. Do I need to count every single counter in this tens frame? No. Because it's full up, I know there are 10 in there. So I'm going to count on from 10 and count these ones up the top. So I've got 10, 11, 12, 13, 14, 15, 16. And altogether, there are how many counters? Do we need to count every single counter? No, we can do quick maths because we can see that this tens frame is full up, so that makes 10, and we already know that this tens frame is full up, and that made 10. So we don't need to do any counting of the counters, we just need to know that 2 tens are worth 20. Now we can fill in our number sentences. So we had 4 black counters and we had 16 red counters. That made 20 altogether. Now remember, addition is commutative, so we can flip our numbers. 16 red counters add 4 black counters equals 20 altogether. Super. This time I'd like you to pause the video and have a go at filling in all of the empty information by yourself. Okay, let's go through with some answers. So How many black counters are there? So we've got a complete tens frame there and one more here. So we didn't need to count all of these counters up here because we know that if the tens frame is full up, there are 10 counters in there. So you've got 10 in there and one more here. That makes 11. Now we need to do our red counters. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 red counters. Altogether, there are how many counters? So we already know that this tens frame is worth 10 because it's full up, and this tens frame is also full up, so that is also worth 10. And if we have two tens together, then we have 20 counters altogether. Now let's fill in our number sentences. So we had 11 black counters and we had 9 red counters. That makes 20 counters altogether. And because addition is commutative, we can flip those numbers round and still have the same answer. So we had 9 red counters and 11 black counters. That makes 20 counters altogether. Okay, let's do some reasoning. So we have a problem here and we need to say if this is true or this is false. Let's read it together. There are 9 black counters. There are 5 red counters. Altogether, there are 15 counters. True or false? Explain how you know. So have a look at that question. What do you think? Pause the video here to have a think. Okay, let's go through it together. There are 9 black counters. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that bit is true. There are 5 red counters. Let's check. Let's just change the pen so we can see. 1, 2, 3, 4, 5, 6. No, that is not true. Altogether, there are 15 counters. 10, 11, 12, 13, 14, 15. That part is true. Is it all true? No. So you have to say it's false. How do we know it's false? Because there are 6 red counters. Well done.